Hello, my name is Mr. Kelvin from Educare TV. Welcome again in our lecture session, and today we have presentation based on Form 2 Physics, and we proceed with our topic, which is motion in a straight line. And in this, we already covered some of subtopics. Among of them include distance and displacement. Tumeshaona kuhusiana na distance pamoja na displacement, lakini pia tumeshaona kuhusiana na speed and velocity. And today we will not go to look acceleration because we look it on the calculation part, but we will go to look equations of uniform motion, kwamba equation za uniform motion zikoje, tutaziona na ziko vipi. Na lastly tutadiscuss motion under gravity. By starting with equations of uniform motions, a scientist known as Newton, he became with a deduction of three forms of equations of motion. We have about 3 equations of linear motion as introduced by Sir Isaac Newton katika mwaka wa 1886, which among them include Newton's first equation of motion, Newton's second equation of motion, and the last one is Newton's third equation of motion. So in our today's session, we'll go on looking how we can arrive in those 3 equations. By starting with Newton's first equation of motion, kwamba kwa kuanza na equation ya kwanza ya motion, we say that it is related final velocity, initial velocity, acceleration and time. Kwamba hii equation ya kwanza inahusianisha final velocity, initial velocity, time pamoja na acceleration. The Newton's first equation of motion, it is given by v is equal to u plus at. Kwamba ukichukua v is equal to u plus at, v ni nini? Tukizungumzia v tunamaanisha ni final velocity, but u tunamaanisha initial velocity. A katika formula yetu tunamaanisha ni acceleration na t tunamaanisha ni time. So kama tulivyosema, tunataka to prove kwamba the equation kweli ndo yenyewe. Tutaanza kwamba from a is equal to v minus u over t, kwamba acceleration ni sawasawa na change in velocity over time. Hilo tunalijua wote kwamba when we take acceleration is equal to change in velocity, then you divide by time. But when you multiply by time both sides, means you multiply by time in this side and in this side you multiply by time. Kwa hiyo ukizidisha na muda kwamba itakuwa ni acceleration times the time is equal to v minus u. Hapo utakuwa umezidisha pande zote mbili. But we say add u both sides. After multiplying t both sides, then add u on both sides. Means if we add u and here u, means negative u with positive u will cancel out. So we remain by at plus u is equal to v. So v is equal to u plus at. That is only rearrangement of the equation, and we get the Newton first equation of motion, and that is how you can drive that expression. Hivyo ndivyo unavyoweza drive hiyo equation ya motion na ukapata jibu lako. Lakini tukienda katika Newton second equation of motion, katika equation ya pili ya motion as proposed by Sir Isaac Newton, tunasema kwamba it relates distance, ambao kwenye mabano tunasema displacement moved, also ina relate initial velocity time and acceleration, kwamba katika hii equation ya pili ina relate vitu vifuatavyo. Kitu cha kwanza ni distance, ambayo tunaweza tukasema ni displacement. Kitu cha pili ni initial velocity. Kitu cha tatu ni time taken, na kitu cha mwisho ni acceleration. Kwa katika hii formula hatutaona final velocity. Kwa hii equation utatumia endapo katika hizo data zako ulizopewa hamna final velocity. Kwa hiyo tunasema kwamba Newton's second equation of motion is given by S is equal to ut plus a half at square. Hiyo ni Newton second equation of motion, kwamba S inamaanisha nini? S inamaanisha ni displacement au distance, lakini U inamaanisha nini? U inamaanisha ni initial velocity. T inamaanisha nini? T inamaanisha ni time taken. Na A inamaanisha nini? A inamaanisha ni acceleration. So the Newton second equation of motion relate as S is equal to ut plus a half at square. Now tunataka tu prove kwamba hii kitu imepatikanaje au hii equation imepatikanaje. Now consider from Newton first equation of motion, kwamba kutokana na first equation of motion tulisema kwamba V ni sawasawa na U plus AT au AT plus U ni sawasawa na V. But we know that average velocity, kama tulivyosema kule kwenye definition, kwamba average velocity ni sawasawa atakayechukua initial velocity aka plus final velocity then akaganya kwa mbili. Hapo atakuwa amepata average velocity. Kwa average velocity nikichukua initial velocity nika plus na final velocity nikiganya kwa mbili nitapata average velocity. Lakini pia nikichukua displacement nikagawanya kwa time nitapata pia average velocity. Kwa hiyo basi naweza nikasema kwamba average velocity ni sawa sawa atakayechukua displacement au distance gawanya kwa time, ambayo ni sawa sawa na final velocity plus initial velocity gawanya kwa mbili. So nitarelate hizi equation mbili, equation ya displacement over time na equation ya average velocity. So nikirelate itakuwa S over T is equal to U plus V over 2. That is the relation. Then we can say that S over T is equal to U plus V over 2. Then let's make S as a subject, kwamba tutengeneze distance iwe ni kama equation ya motion. Tunasema kwamba S over T will be equal to U plus V over 2. Then tuna multiply by 2 both sides. If we multiply by T in this side, T na T will cancel. And if we multiply in this side means U plus V over 2 times T. Then you will get S is equal to U plus V into bracket T over 2 as it is written above. Also, but we know the formula of finding the final velocity is equal to U plus AT from the first equation of motion. So we say that from the first equation of motion, V is equal to U plus AT. Then substitute this value of V into our equation above. Substitute the value of V into our equation above to see what kind of equation you can get. So if you take V and you substitute in the equation above, you get S is equal to U plus V into the bracket T over 2. Then S is equal to U plus U plus U. First U is in our formula, but V is equal to U plus AT. So it will be U plus AT. This is V. Then you will divide by T. You times the T and you divide by 2. So you will get S is equal to 2U plus AT times T over 2. So if you open the bracket, means you multiply by T inside of the bracket, means it will become S is equal to 2U times T, which is this one, plus A times T times T, which it become T square. Then you will divide by 2. So it will become S is equal to, now open the bracket by dividing by 2 in this side and by dividing by 2 in this side. So it will become 2 and 2 will cancel, remain UT, that is as written here, and also AT square, it will become a half AT square. So that is how you can prove the second Newton equation of motion. It is simple. Go through the steps we analyze and you can reach to the end of the proof of that equation. Now let's consider also the Newton third equation of motion. How can we prove? Kwamba tunaweza kuprove vipi Newton third equation of motion? Tunasema kwamba it relates to final velocity, initial velocity, acceleration and distance moved. Kwamba hii third equation of motion ina relate vitu vifuatavyo. Kitu cha kwanza ni final velocity, kitu cha pili ni initial velocity, kitu cha tatu ni acceleration na kitu cha mwisho ni distance moved. Kwa hiyo katika final velocity tuna v, katika initial velocity tuna u, lakini katika acceleration tuna a, lakini pia tuna s. Kwa hiyo katika formula yetu tutaenda kuona hivyo vitu, tutaenda kuona u, tutaenda kuona v, tutaenda kuona s pia na a. How they are relating, zina uhusiano upi? Now we say that the Newton third equation of motion is given by v square is equal to u square plus 2as. Now we have to prove this formula. V square is equal to u square plus 2as, where v is equal to velocity, final velocity, and u is equal to initial velocity. 2as, 2 is a constant, a is acceleration, and s is displacement or distance moved. Now, as we can see the proof from the Newton first equation of motion, we see that v is equal to u plus at. Now, square this equation both sides. We will get v square is equal to u plus at square. You will get, if you take u plus at square, you get v square is equal to u square plus 2uat plus a square t square. This is the difference of 2 square. So utafungua mabano kwa kuchukua u plus at mabano times u plus at mabano. Kwa hiyo utazidisha u times u utapata u square, u times at utapata u at, also uta plus at times u utapata u at plus a t times at utapata a square t square. Then itakuwa v square sawa sawa na u square ambao ni huyu hapa plus ukichukua uat ukajumlisha na uat utapata ni 2uat, uta plus na a square t square. Kwa hiyo itakuwa ni v square sawa na u square plus, ukiangalia hapa kuna common term ambao ni 2a. Kwa hiyo utatoa 2a into the bracket, tabaki ni ut plus hapa kwa kuwa hamna 2 itakuwa ni half at square. Then baada ya hapo itakuwa, lakini tunajua kwamba s sawa sana ut plus half at square. Ukirudi hapa nyuma tumekuwa na ut plus half at square, ambapo hichi kitu tulisema ni nini? Ni s au ni displacement au ni distance. Kwa hiyo hichi tulichokifungia mabano hapa ut plus half at square, hichi ni sana mtu aliandika distance au displacement. So instead of writing ut plus half at square tutaandika s kama inavyoonekana hapa. So the above equation will become v square is equal to u square plus 2a into the bracket s. If you open bracket, it will become v square is equal to u square plus 2as. Hapo utakuwa umeweza kuprove Newton third equation of motion. Hivyo ndivyo unavyoweza ukaprove hiyo equation. Lakini pia there is alternative on proving this equation. We say that Newton's third equation of motion can be derived by eliminating t from the Newton first equation of motion. How can we eliminate this? Let's go together and check if we can arrive into the answer. We say first equation of motion is equal to v is equal to u plus at. Then let's make t the subject of the formula. We make t the subject, it will become v is equal to u, means this u will be subtracted in this side, then it will become a t. Then divide by a both sides, it will become t is equal to v minus u over a. That is equation number 1. So from s over t is equal to u plus v over 2. So now s over t is equal to u plus v over 2. Then make s the subject of this formula. If you make s the subject, means you will multiply by t in both sides. If you multiply by t in this side and this side, it will become s is equal to u plus v into the bracket t over 2. Let's call this equation number 2. Also, substitute equation 1 into equation 2. We get s is equal to, into the bracket, another bracket u plus v into the bracket also v minus u into the bracket, divide by a, bracket divide by 2. So you will get 2s. When you multiply by 2 in both sides, you get 2s is equal to, into the bracket u plus v into the bracket, also open the bracket u minus v minus u into the bracket over a. Then divide by a in both sides. You get 2as is equal to u plus v into the bracket v minus u. Then this is what we call difference of 2 square. If you open this by using difference of 2 square, you will get v square minus u square. So it will become 2as is equal to v square minus u square. So v square will be equal to u square plus 2as. And that will make the end of the proof of the Newton third equation of motion. Hivyo ndivyo unavyoweza ukaprove hizo equation zote tatu za motion, kwa kuconsider kwamba hii equation ina relate vitu gani na naweza nikaiprove vipi na kwa condition hipi. Kwa kusema hivyo, let's have a task to do, because we learn about how to drive, how we can prove those Newton equations of motion. So your task is to drive all the 3 equations of motion to check if you understand them, if you can manipulate them to get various kind of equation which you can use within the motion straight line. By saying so, thanks for watching. Stay tuned for the coming lesson. Have a nice time.